You've probably heard of the Collatz conjecture. Yeah, that one. The simplest, most dangerous problem in math. But what if it's not really a math problem at all? What if, and stick with me here, what if it's actually a story about the fundamental stability of the universe itself? Okay, let's dive into this wild idea.
The whole perspective we're exploring today asks us to just stop. Stop looking at Collatz as just a random string of numbers. Instead, we need to start seeing it for what it might be. A miniature creation story, a cosmic battle between chaos and order that's playing out inside every single integer.
So a quick refresher. The rules of the game are famously, deceptively simple. You grab any positive number you want. If it's even, cut it in half. If it's odd, you triple it and add 1. And then you just keep doing that to the result. That's it. Sounds easy, right?
Well, here's the hook. Every number we've ever tried, and I mean we've thrown quintillions of numbers at this thing, they all eventually fall down a rabbit hole and get stuck in this tiny little loop, 4 to 2 to 1, and then back to 4. It seems like all roads, no matter how crazy, all lead back to 1.
But why? I mean, really, why? Why this universal collapse? Is there some kind of hidden law, some invisible gravity that's pulling every single number, no matter how astronomically huge, back to this one humble cycle? Now that is the real question. And to answer it, we have to totally change how we even think about what a number is.
The core idea of this new proof is that every number isn't just one thing. It's actually living in two completely separate realities at the exact same time. You can think of it like an upstairs and a downstairs, a world of chaos and a world of order.
And this framework gives them these awesome names. Upstairs, you have the turbulent, noisy sky. This is the world we know, right? The world of size, of magnitude. This is where that 3n+1 rule lives, the twist, the thing that makes numbers leap up and seem totally random. But underneath all that noise is the crystalline ground, a hidden world of perfect structure, all about divisibility. And that's where the n divided by 2 rule lives, the resolution, the move that always brings things back toward order.
And here's the thing, this isn't just some fun metaphor, it is a stone-cold mathematical fact. Over a century ago, a proof called Ostrovsky's theorem showed that there are only 2 fundamental ways to measure the size of a number. There's the normal way we all learn, its magnitude, and then there's this other wild way based on its prime factors, using something called p-adic numbers. The noisy sky and the crystalline ground? Yeah, they are real mathematical places.
So here's the big reveal. The reason Collatz seems so impossible, it's because we've been watching the show in the wrong theater. We're staring up at the chaos in the noisy sky. But if you could put on a pair of magic glasses and see the crystalline ground, the world of 2-adic numbers, where divisibility by 2 is everything, the function is perfectly smooth. It's continuous, it's totally well-behaved. The problem isn't chaotic. Our viewpoint was.
This table basically just lays it all out. It maps these cool concepts right onto the formal math. You see the noisy sky? That's the world of real numbers, home of the 3n+1 operation. The crystalline ground? That's the 2-adic numbers, home of the n/2 operation. And what's really mind-blowing is that there are these high-level math tools, like something called the Adele ring, that lets you see both worlds at the same time, revealing this hidden symmetry that's running the whole show.
Okay, so we've got this arena, these 2 worlds where the battle takes place. But what about the destination? We said all numbers fall into that 4-2-1 loop. Well, according to this framework, that's not even close to the whole story. The real destination is so much bigger.
It's not just some tiny loop that numbers happen to stumble into by accident.
Yeah, instead, it's this enormous, intricate structure. A whole landscape that's actually generated by the rules themselves. A landscape that all numbers are already living in.
The source material calls this thing the golden set, and the best way to picture it is like an infinite tree. The trunk is that little 1-2-4 cycle, and the branches are every single number in existence, each one on a path that eventually leads right back to that trunk. Every number, everywhere, is already part of this one single cosmic tree.
So how can we be so sure a structure like this even exists? Well, we use something called an iterated function system, or an IFS. It sounds complicated, but it's really just a mathematical way of showing how you can take super simple repeating rules, kind of like the Collatz rules, and have them give birth to these incredibly complex, beautiful fractal patterns.
And here's the kicker. A really powerful result called Hutchinson's theorem basically proves that if you look at the Collatz rules in the right place, not in the chaotic noisy sky, but down in the orderly crystalline ground, they are guaranteed to generate one single unique fractal attractor. The existence of this golden set isn't just a guess, it's a mathematical certainty, as long as you're looking in the right universe.
All right, so we have the arena, the two worlds. We have the destination, this giant fractal golden set. Now for the final, most important piece of the puzzle, the mechanism. What's the engine that actually forces every single number to fall towards this destination?
Let's go back to that idea of a cosmic battle. On one side, you've got the twist. That's the 3n+1 rule. It's a force of expansion, of chaos, making numbers get bigger in the noisy sky. But on the other side, you have the resolution. That's the n/2 rule. It's a force of contraction, of order, pulling numbers closer together down in the crystalline ground. Every step in the Collatz process is one move in this cosmic tug-of-war.
And the entire legendary Collatz conjecture, it boils down to one simple, profound claim. In this battle between chaos and order, order always wins. The force of resolution, working away in that hidden world of structure, is just fundamentally more powerful than the force of the twist, that's making all the noise up in the world of size.
But how on earth do you prove something like that? You need a referee. You need a way to keep score in this battle, a tool that can see both worlds at the same time. And that tool, it's called the Arakelov height. Just think of it as a universal complexity score for any number. It's one single value that you get by adding up a number's size in the noisy sky with all its structural properties from the crystalline ground.
Okay, so here's how the trap finally snaps shut. You look at the whole system in that unified space that sees both worlds. When you do a twist, the 3n+1 part, the number gets bigger and its complexity score ticks up a little bit. But, and this is the whole key, that step always creates an even number. Always. Which means you are forced to then do a resolution, a divide by 2 step. And that step, it causes a much, much larger drop in the structural part of the score. The tiny gain in chaos is always overwhelmed by a massive loss in complexity. The crystalline ground is the dominant force, period. It guarantees the score must always go down over time, forcing every number to inevitably collapse to the one and only state of minimum complexity, that tiny 1-2 cycle.
So, after all that, we're left with this one enormous question. Is this simple little pattern, if it's even, divide by 2, if it's odd, multiply by 3 and add 1, is it just some random meaningless quirk of our number system? Or, as this incredible framework suggests, is it actually a tiny glimpse into a universal law? A law that says that in any system defined by a tension between chaos and structure, structure will always, inevitably win, ensuring a collapse to a stable, simple origin. A fundamental law of cosmic stability, written into the very fabric of numbers themselves.